You are walking along a straight mountain road with an 8% grade. Ahead you see a tree standing perfectly plumb alongside the road. From a point on the road 400 feet downhill from the tree, the angle of inclination from the road to the top of the tree is 6 degrees. What is the height of the tree to the nearest tenth of a foot? Alright, so let's get a visual of this. Here we have our road with our inclination looking up at a tree, and plumb means it's perfectly square to the horizontal. So let's first of all figure out what we know by knowing that it's an 8% grade, and that's essentially telling us it's like rise over run. We go up 8 for every 100 over. And so we could use that to determine this angle right here, because we do have a right triangle, and so we can see that tangent of, we'll call that angle theta, is going to be 8 over 100. So let's get the calculator and figure out what theta would be. We're making sure we're in degrees, and we're going to do inverse tangent of 0.08, or 8 divided by 100, same thing. And it looks like we get about 4.57 to 2 decimal places, so 4.57 degrees. So now, as we look, one of the other pieces of information we have in the problem is the angle of inclination from the road to the top of the tree. So if we're down here and we look up to the top of the tree, this angle right here is 6 degrees. And then the other piece of information that we know is that this is 400. Now this 8 and 10 was actually to get the ratio because it was in a percent, and so those two sides of that right triangle aren't 8 and 10. There'd be some multiple of those so that the hypotenuse is 400. So I'm taking those off. It's okay to do that because we knew the ratio was 8%, or 8 out of 100 is what we'd get. So we're good there. Now let's see what else we've got and what we want to find. We're wanting to find the height of this tree, and so that is the side of this oblique triangle, and we could figure out this angle because we know the tree is plumb, so that's a 90, and then this other little angle right here would have to be the same size as the angle down here. You can see our parallel horizontal lines, and we've got those alternate interior angles. And so this little angle right here must be 4.57 degrees as well. So we can figure out this entire angle in the triangle is going to be 94.57 degrees, the 90 plus that little piece. So now, looking at our oblique triangle there, that top triangle, we have an angle, a side, and an angle. So we can figure out what we want, which is the one side of the triangle, h. So we're going to use the law of sines, and we're going to say h over the sine of the angle opposite h, which is 6 degrees, is going to equal 400 over the angle opposite the 400. We don't have written in, but we can find it. It's right here. And so if we take 180 and we subtract 94.57 and subtract 6, we will have that angle at the top. So that looks like this angle right here will be 79.43 degrees. So sine of 79.43 degrees. So we'll multiply the sine 6 over here, and then we will grab the calculator and compute that. Always when you grab the calculator, make sure you're in the right mode. We are in degree mode, so we've got 400 sine of 6, finish the angle there with the parenthesis, divided by the sine of 79.43, and that should tell us the height of the tree. We want to the nearest tenth of a foot, so that's going to be 42.0 5 feet. So height is approximately 42.5 feet.